This is Rick Haskell, and today we're going to take a look at the midterm exam 1 that was had or taken for our students in Labor Economics Econ 3100, Section 90, and this was taken on October's 9th and 10th. In this 3-video unit, I'm going to go ahead and review each of the 3 segments or sections on the exam, and look at the questions and look at the answers that I came up for these questions prior to giving you the exam. So first, in the first video segment, we'll take a look at Part 1 or Section 1, which includes problems 1 and 2. In the second video, we'll take a look at Part 2 or Section 2, in which we had problems 3 and 4. And then the third video and final, we'll take a look at Section 3 or Part 3, which had just one question in it. So as we do that, I'm going to review briefly the question and maybe point out some items inside of the question that I thought were important to consider. I'll look at the answers as well. You can compare these to the answers that you gave, and maybe this will even help you better understand some of my red notes that I put on your exam as I scored it and then scanned it and emailed it back to you. So take a look at this, and hopefully if you got some things wrong here, or if you weren't quite right in your thinking, hopefully this will let you focus in or hone in a little more clearly, so that when you see these same metrics perhaps on another exam, that you can perform yet better still on this. So this first question in Part 1 has to do with BJSG Ribs in Mankato, Minnesota. Obviously, this is a fictitious firm, but this particular firm is in a competitive labor market, which means there's other firms in the market competing for the same workers, which also means that once there's been a wage that's identified, an equilibrium wage established, the firm really can't change that wage without risking overpaying employees or underpaying, in which case they're not going to have any employees. It's also a competitive goods market, which means that once the price of the output good has been established, then that's the price regardless of the quantity, just as the wage that's established is the wage regardless of the quantity that might be selected by the firm. So as we look at this, you are given a column with wages from $6 to $10 per unit, I'm presuming per hour. You're given some number of quantity of output that might be commensurate with that wage. And of course, that's then making a presumption that that wage, when placed into the demand equation for the firm, is going to result in some labor demand or some number of workers. So in this case, to identify and properly populate the labor demand column here, we're going to take the wage and substitute it for W in the labor demand equation and then solve for labor demand. So in the case of the first row, we have 75 minus 6 times 6 is then equal to 39. And you continue that same metric on down through each one of the different wage levels that you're given here. Now, virtually everyone that chose this particular problem got that right, and so I don't think there's any problems there. But there were some problems in marginal product of labor. Recall that the marginal product of labor, which is MP of L, is equal to some change in quantity of output good given some change in labor. Well, so we have to look at this. Our quantity of output good is the Q. So here we don't have a change in labor coming into this first row, so we don't really have a marginal product of labor in this first row. But as we go down to the second row, we now know what our change in labor was and our change in quantity. So we have a change in quantity of 5. In this case, it's negative 5. We have a change in labor of negative 3. Well, negative 5 divided by negative 3 is positive 1.67. And that's how you provide answers for each one of these cells. So you can see the correct answers as we go through here, and each time it's just the change in quantity divided by the change in labor. We know that the marginal revenue product of labor is equal to the marginal product of labor times some output price. And the output price was given at $3 per rib, or per unit of ribs. And we have the marginal product of labor, so literally we're simply going to take that value of marginal product of labor, multiply it by 3, the price, and we're going to end up with the MRP of L column here. So we had 5.01, 6, 6.99. Honestly, this 5.01, 6.99, 8.01, those are close enough to just 5, 7, and 8 that I would have accepted those answers. Similarly, down here a little further, these are close enough to 10 and 11. I would have accepted those answers. So what we see here is that the marginal revenue product of labor and the wage are virtually identical at 27 workers. So in this case, absent any other information, we didn't have a supply relation, we didn't have a cost relation or a marginal expense relation that we knew we could rely on here. That information wasn't expressed or requested. Then we see that we're looking for, in a competitive market, an optimal number of workers at some level of output, which is commensurate with the wage being equal to the marginal revenue product of labor. That was one of our optimizing conditions. Well, so for item B then, is just answering that. How many workers and at what wage? Well, 27 workers at $8. Part C asks us if the firm noted that its marginal product of capital, so MP of K, at the number of workers you indicated were equal to 30 and the price of capital was equal to 45, what would you recommend the firm do? Well, think about this. You know an optimal marginal product of labor now. You know an optimal price of labor. And the marginal product of labor, of course, at optimality was 2.67. So if we come here, we can say, does this fit within our balance condition? And I didn't expressly tell you I wanted a balance condition, but I gave you information saying that we wanted to reach some profit maximizing level. And if we ended up with this MP of K and P of K, so price of capital and marginal productivity of capital, could we use some metric that we've studied? Could we consider how to reach this? And if so, what would we do about it? Well, this is the balance condition, and that we studied in the marginality section of the course so far. So we're looking for a relationship in which we can have marginal product of labor divided by the price of labor equal to the marginal product of capital divided by the price of capital. And here we're given the marginal product of capital and the price of capital, so 30 and 45. So that gives us some equation or some quotient that's going to equal 0.667. And if you think about the marginal product of labor at 2.67 and price of labor at 8, we immediately see that that equates to 0.334. So those two terms are not equal to each other. So the question is, what do we do to make them equal to each other? Well, we're given marginal product of capital and price of capital. Even if had those not been given to us, we know that as a competitive market, we can't change the price of capital. We can't change the price of labor either. This is a competitive market. We are price takers, not price makers in these markets. And in this case, we can only change capital productivity in the long run, and that's not a decision that we can make easily right now, so we're not going to change the marginal productivity of capital, which means the only thing we're left that we might be able to influence is the marginal productivity of labor. Well, if we want to bring these two terms into equality or into equilibrium, we're going to have to make the left-hand term larger, because right now it's about half the size, half the value of the right-hand term. Well, the only way to do that is we're going to have to increase the value of the numerator. So we're going to have to increase marginal product of labor. And the way to do that is to employ fewer workers. So if we have fewer workers within our facility, we know that based on the law of diminishing marginal productivity, that will increase the productivity expected per worker. And we can do that to some point, which is going to bring this into equality. So that's what we were looking for here. And then part D asked, what would be the implication of the adjustment that you just recommended? Well, the firm's in a competitive labor market and appears to be paying $8 an hour. So we're going to be paying that pretty much regardless. But if we have marginal product of labor increasing, we also have marginal revenue product of labor increasing. And we would then end up with some kind of inequality such that we would probably find ourselves in a position such that wage was less than marginal revenue product of labor. And that might not otherwise be an optimal condition. that's something you're going to have to think about a little bit. In fact, is the firm even able to sustain that, or is some other competitive structure going to bring that back or cause that to erode over some period? Well, maybe it would, and maybe that period would be long enough that in the interim the firm can make some capital changes such that they can then change the marginal productivity of capital as well. But we are almost certainly going to end up, at least for some short term, in a scenario in which wage is less than the marginal revenue product of labor, which means that the firm is going to have some excess profitability as a function of labor's input during that term. So as we go to problem number 2 then, we're looking at John. And John's a college graduate. He's a mid-level executive in a technology firm. He's making $40 an hour. He's got investment assets of $50 per day in personal income, or $250 a week, so 50 times 5 days out of the week. He's got a daily budget requirement of $400. He's supervisory, so he doesn't get any overtime. His employer allows him to work and pays him for as many hours as he wants to work, but only within a 5-day period. So that's kind of our backstory here. And then you're asked if John kept his number of working hours constant at his wage, or as his wage increased beyond $40 an hour, what would you tell me about his labor-supply relation? Well, and I've asked you to give a simple illustration, but give me some specifics in terms of what you think is going to take place here. So let's first consider the illustration. So I've gone ahead and given us a basic labor-leisure trade-off model. And I've just noted that we've got some leisure hours here. I could have just as easily put some labor hours underneath it. I don't have to, but I could have. And instead of starting it at 0 in terms of the income, I've started it at 50, simply so that I didn't have to represent the effect of the $50 endowment. Now you might have done this differently, and that would have been fine. You might have started it at 0 and then gone ahead and represented that effect by having some vertical line here, and maybe our axis would have been down here at 0. At any rate, our first line that we're going to think about is this line that goes from 16 on the leisure curve straight up until we hit the 50 on the income, and then a line that moves from there up to 690. 690 being 50 plus 40 times 16 hours of labor that might have existed. And so we've said if he's going to work some specific number of hours, I haven't said what that is, so I'm just saying it's 16 minus the number of hours he'd work, minus L. And I've got a line going straight up to that, and that's going to give me some income that he would receive. And we know that that would have to be 400 based upon the story that we're given. And then if he gets a raise, which means he's going to have more than 40, then we've got a different curve that develops. This one has a slope that is greater than the absolute value of negative 40. This slope is negative 40. This one's going to be greater than the absolute value of negative 40 because the wage is going to be greater than 40. And we know that the slope of this curve in the labor-leisure trade-off model is the negative of the wage. So we know that'll be greater than 40 here, but it's going to be negative because it's downward sloping. And so if we move his number of hours up, because I said he wasn't going to change his number of hours based upon this new wage, then we would see that he'd receive some wage or income inclusive of his $50 endowment each day that's going to be up here, and it'll be simply greater than the one before. So this is what this looks like. I've added a couple of indifference curves here, which you didn't have to do, but I think are instructive. So I've added these indifference curves so you can see how this might look. And of course, if this individual receives utility, happiness, satisfaction from some combination of labor and leisure and some income, well, we would expect that at some number of hours of leisure and a given income, that the person receives this utility or this satisfaction level, and that if the number of hours of leisure remains constant but the income goes up, that the individual, John, is going to receive yet more utility or more happiness or more satisfaction. So we've got our indifference curve shifting out and to the right, just as we would expect. So that's what I'm looking for here. And I've simply explained, it tells me that John has a constant preference for a certain labor-leisure ratio without regard to his income, which I think is illustrated fairly well by the graphic I provided you. We go to part B then, assuming John's a participant in a competitive labor market, the output price of the firm's product is $1,200, as that's the price of the good that John's is producing or helping produce. What can you tell me about his weekly marginal productivity? Well, okay, I know the marginal product of labor is equal to change in quantity divided change in labor, and the marginal revenue product of labor is equal to marginal product of labor times P. So if I assume that MRP of L is equal to wage, then I know that I've got wage being equal to the marginal product of labor times the price of labor. Well, do I know the price? I know a weekly wage. Or rather, not the price of labor, excuse me, marginal product of labor times the price of the output good. Please excuse me. So what I know is I know what his wage is. I know he's earning, based upon some number of hours a week or some requirement a week, I know he's going to be earning $1,750. And I know that because I can look at his budget requirement. His budget requirement, if you think about it, from labor, his labor's effort is $350 a day. He needs $400 a day in income, of which $50 is coming from his endowment. So he's got to earn $350 a day times 5 days a week. That's $1,750. So I know then that I've got $1,750. It's going to be equal to some marginal product of labor times the output good price. Well, that's $1,200. We're told that. So I can then rearrange this. 1750 divided by 1200 is equal to his marginal product of labor, which was equal to 1.4583. If you had just answered at 1.49 or excuse me, 1.46 or even 1.45, I would have been happy with that. Very few people got this. The ability to think beyond just the obvious structure of the equation was challenging for most of you. You may remember that I did an example of this exact structure in one of our video segments. So as we move on to part C then, I say provide a properly labeled and appropriately articulated labor-leisure trade-off model representing John's daily decisions. And to give me some representation of his tastes and preferences. And so what I've got here is exactly what I described back in this first question, or part A. Part A. And so I've gone ahead and given ourselves a leisure line in the x-axis and a labor line. We go from 0 to 16 and 16 to 0, just as we would expect in this kind of a model. We know that the human being has 24 hours in a day. We presume that 8 hours of that needs to be spent in regeneration, so there's 16 hours available for labor. We've seen this before. And if this individual with a $50 endowment each day has 16 hours of labor, they still get a $50 endowment each day. So we've got a vertical line from the 16 on the x-axis straight up to 50 on the y-axis. And then we have a negative 40 slope because, remember, that's the hourly wage. And we know that we're going to take that up to 16 times 40 plus 50 to get to the 690. And so we know John needs $400. Well, we also know that to get $400 in income, he's going to have to earn $350. Well, $350 divided by the $40 of income means that he's going to have to work 8.75 hours a day. It means he'll have 7.25 hours of leisure. So he's going to interact with this labor-leisure trade-off at this point where we have an income of $400 and a leisure of 7.25, and that's the point at which his indifference curve representing his happiness or utility is also going to be tangent to the budget curve. Then finally, I said, given what you know about John, how would you describe his relative skill level and his overall level of utility? Got some really interesting answers on this, and they were really ranging. What I didn't get from many of us was some understanding that it must be a fairly highly skilled person. This person's making $40 an hour. And if you think about that, $40 an hour, not an insignificant wage. If we've got that at 40 hours a week and 52 weeks a year, that's $83,000 of wage earnings plus his $50 a day of endowment. He's bringing in $91,000 a year. Forget the endowment for a moment. The $83,200 is not an insignificant dollar amount. That would represent a relatively highly skilled individual, which you would expect given his supervisory responsibility, his years of experience, and his education. So some discussion in here about that skill level, the fact that he's got a budget preference, he's getting some optimal utility there. I apologize, you can't read the very bottom as it got cut off in the scan, but this bottom note says his budget preference of $400 a day might also suggest he's at optimal utility since he could increase income utility with more labor, but is choosing not to. Anyway, so that's the way we would approach that particular problem. So that's number 1 and 2. In the next segment that we'll go through in a few moments, we'll take a look at 3 and 4.